Hello friends, today I am going to discuss NumPy. This is the part and also used in Python. So this is the library, very important library in Python. So you can say just import NumPy as NP. So I have imported NumPy as NP, and now I am going to discuss reshaping and resizing. Just rearrange arrays. Okay. So when working with the data in array from, then we need to understand, it will be useful to rearrange array and alter the way they are interpreted. So suppose I have n times n matrices array could be arranged into a vector of length n square. So the set of the one dimensions array could be concatenated, means it can be added together or stacked next to each other and to form matrices. So NumPy MPY, I think this one NumPy as a NumPy, right? So let's see. So how to reshape np.reshape? I can use the functions here. I can say the methods. So reshape the n dimensions array. np.ndarray.reshape remain the same. np.ndarray.flatten create a copy of the n dimensions array. np.revels create a view. np.ndarray reveal in which the interpret the one dimensions array. np.switch remove axis with the length 1. np.expand underscore dims add a new axis. np.new axis, so new axis is used with the array. np.transpose the array. np.ndarray.transpose and np.ndarray.t as a transpose. np.hstacks stacks a list array horizontally, and np.vstacks means stack a list of array vertically, and np.dstacks means stack array depth wise, and np.concatenate create a new array by appending array after each other along a given axis. So np.resize means resize an array. np.append means append elements to the array, create a new copy of array. np.inserts the new. So similarly, let's see that I am going to create data will equal to np dot array and parenthesis first 1 comma 2, and now another bracket has been started 3 comma 4. So we need to the, because one is this and another square brackets. Okay, so now another just np.reshape I am going to look here. So I have created ARRAY. So I have created a variable data, and this one is the first array. So we can see the data as look like this. So data means it has been created this type. You can also see the data type, data dot type, right, d types. So we can also size d types, sorry, data dot b type, so dimensions of this type here, so we can easily see. And another thing, just look here, so how to reshape this arrays. And so we need to like here the np dot reshape, np dot reshape, reshape, and because I am going to the reshape, data comma bracket start, and I am look like a 1,4. so this one has been a reshape. Look here, np dot reshape look like this. So 1 2 3 4 has been created, 1 2 3 4 till 4. Similarly, if you want to reshape from till 3, so is it possible? It can be the reshape, yeah. Okay, so no, because I have taken a till 4, so we need to take greater value is here 4. So it will be look like a reshape, means you can see here 1, 2, 3, 4. But other way we can also write here data dot reshape. So data dot reshape, and you write the maximum value is a 4. So you write here the data dot reshape, so it will create it automatically 4. If I want to write here the 8, so it will be create, but we don't have the 8 values, so we to the only we can create, because data is a variable, so we don't have the 8, so we are not able to create. So I hope it is clear. So it is necessary that the requested a new shape of the array match the number of elements in the original size. So look here, this one is the original size. So another way, just I have already created data as this, and it has been gotten the output look like this. So now data I am going to use ndArray method flatten, perform the same functions but return a copy instead of view. So np dot data, you can also data dot flatten we can use here, and this one data dot flatten, and you can look this what happened, look like just look like reshape and flatten both are similar. But if you like to data dot flatten and dot shape, right? So now look this data dot flatten, I think, okay, look here this one, and then look like this. So data dot flatten dot shape, don't need a parenthesis because yeah, so you can see the 4 comma. Similarly we can use here np dot revel, np dot flatten, collapse the axis on the array into the one dimensions array. And it is also possible to introduce new axis into an array. So either by using np.reshape, and when adding the new empty axis using indexing notations np.newAxis keyword. So let's see, just I am going to create the new data here, and data will equal to np.arrange, and I am going to write here 0,5, and now I want to print data, right? So let's see, data has been printed. Look like data np arrange, not arrange, arrange. Okay, so it has been created. It will start from the 0 to 4, and now I am going to represent here column as look like this, column as a variable, and data this one colon this np dot new axis, np dot new axis. Now I am going to print here column. So look here, just it has been converted as a row into, as look like a your this way, like a column. And now if I write here, if I want to convert into the rows, so to write here row will equal to data and square bracket np dot new axis, comma colon, and this one has been printed as a row like this one. Similarly, just a row has been created like a array. So the functions np, similarly we can use a functions .np.expand underscore dims, can also use the new dimensions to array, and the preceding example like expressions data colon np dot new axis is equivalent to np dot expand underscore dims. And so we have up to now looked at a method to rearrange array in a way that do not affect the underlying data. So the shape of the array passes like a, we can use the np dot vstacks. So let's see, just I am going to create a arrange data. So data will equal to np dot arrange, and I have created file, and now I am going to print here dot. But this has been created as an array, but I want to go here np dot np dot vstacks, vstack, and use double parenthesis. So look here, data, comma, data, and comma, data. So what happened, just it has been created like this way, because I have written here data, comma, data, comma, data. So first we arrange as a this, and it has been created look like this. So if we instead want to stack, similarly if I want to arrange as a np dot stack the array horizontally to obtain the matrix where the arrays are the column vectors, so we might first attempt the something like a similar np dot if you write here np dot hstack, so hstack, right? So hstacks, and you write here again data, and data. So look what happened, just it has been created horizontal way like here, 0 1 2 3 4, again 0 1 2 3 4. So vstacks as a vector way and hstacks like a horizontal way. So this indeed stacks the array horizontally, but not in the way intended here, to make np dot hstacks treat the input array as columns and stack them accordingly. So we need to make the input array two-dimensional array of shape 1 or 5. So I am going to write here, so look here, this type. So let's see, just I am going to write here data will equal to, I have already created a data, square brackets, colon, comma, slice, you can say, no problem, np dot new axis, np dot new axis. So this has been created like this, new axis has been created like this. Okay, but now I am going to write here np dot hstack, stack data, so let's see, it has been created like this way, hstack np hstack look like this. So 0 0 1 1 2 2, this type. So the behavior of the functions for a horizontal and vertical stacking, as well as concatenating array using np dot concatenate. Next, you can also use functions like np dot append, np dot insert, np dot delete. So create a new data. Now another is the vectorizations expressions. So what is the vectorizations? And the purpose of storing a numerical data in an array is to be able to process the data with concise vectorized expressions that represent which are operations that are applied to all elements in the array. So most of the time it is means efficient use of vectorized expressions eliminates the need of the many explicit for like for loops, for loop, while loops, and this results in a less like a code and better maintainability and just a high performing code. So NumPy implements a functions and vectorized operation corresponding to the most fundamental mathematical functions and operations. So many of these functions and operations act on an array on the element wise basis, and binary operations required all array in expressions to be computable size. So most of the time we see the operations between the scalars and array, and scalars being a distributed and operations applied to each elements in the array. Sometimes you can say also when the expressions contain the array of the unequal size, the operations may still well defined. So if the smaller of the array can be brought effectively expanded and too much the larger array according to the NumPy broadcasting rules. So two simple example, look here. Just if I take 3 into 3 matrices and added 1 into 3 rows vector and 3 into 1 column vector respectively, in the both the cases the result 3 into 3 matrices. However, the elements, 2 results and the matrices are different because the way the elements of the rows and columns vectors are broadcasted to the shape of the larger array is different and depending on the shape of the array according to the NumPy broadcasting. So let's try first. This is called like arithmetic operations, you can say arithmetic operations. Right. So first I am taking the x as a variable. X will equal to np dot array and parenthesis double, look here, 1 comma 2 and 3 comma 4. Right. So and second array has been created. Y will equal to np dot array, yeah, so np dot array parenthesis double, and you can write here the 5 comma 6 and comma 7 comma 8 comma 9, right. So it has been created like this. So I have created 2 arrays x and y. Now I want to go here, just you can easily add it, addition, subtraction, multiplication and divisions of the equal size arrays. So we can easily add, no problem, x comma y, this one has been added. Now I want to go y comma x, yes it is possible, you can get here y comma x, and now I am going to the multiply, x will multiplied by y, so you write here x and this will multiplied by y, so you can get output, yeah, x will multiplied. So similarly I am going to the divide here. Is it possible to the divide? Yes, you can write here y divided by the x. So yes, it is possible we can divide and create this kind. So in operations between the scalars and arrays, the scalar's value is applied to the each elements in the array as a one could expected. Similarly, just we can, I want to the first array has been created, so I can easily square of, means we can multiply here the by 2, so the all x, so x array has been, look here, x 11 2 3 4, so 11 into 2 3 into 2 2 into and 4 into 2, look here, 4 into 2 3 into 2 2 into, so this has been created. Now if I like to 2 to the power 2 and to the power x, is it possible to get output? Yes, it is possible to, you can get an output. So look here, it has been 2 to the power, and you can also write the 2 like a double. So if I write here this one 2 and double star to the power x, so yes, you can get a value. Now you can also divide it by, so this one is the another by 2 by 3, so y we can divide it by 2, is it possible? Yes. And now I want to get a data types, let's see. So if I want to get parenthesis y divided by 2 and dot d types, right, so this one has been 4 and 64. So note that the d type of the resulting array for an expressions can be promoted if computation requires it, as shown in the preceding example with a division between integrated array and an integer scales, which in that case result in an array, and you can say that you can easily get the data types. But now I want to the reshape. So reshape means if I write here, so and the arithmetic operations is performed on an array with a incompatible size or shape, a value errors, exceptions is raised. So look here, x as a variable, and I am using np array parenthesis and square brackets. So 1 comma 2 comma 3 comma 4, and now I am going to reshape to dot reshape, but I want to reshape as a 2 comma 2, 2 rows and 2 columns. Is it possible? So let's see. Yeah, so it will be look like this. So x is not look like this, because I think np dot, okay, what happened, just I think I have gotten a mistake here, array, look here, because 1 2 3 4 has been, yeah, it has been reset. Similarly I want to give here z, so I am going to write here z will equal to np dot array and 1 comma 2 comma 3 comma 4, and z will equal to, so now I want to write here x divided by z, x divided by z. So just look here, I have gotten this some error. So operands and could not be the broadcast together. So look here, so here the array x has a shape 2 into 2, but array z has a shape 4, so which cannot be broadcasted into a form that is compatible with 2 into 2. So if one of the other hand z has a reshape shape as a 2 2 1 1 2, then it can be broadcast. So let's do. So first, if I write here z will equal to something like this, like z will equal to np dot array and parenthesis 2 comma 4, right? So array and 2 comma 4. So let's see. So z up, now we can see here np and something, so it has been represented as a z. So now it is working. I think np dot, I have gotten the square brackets, another you can put here square brackets, and look here z dot shape, so z dot shape look like this. Okay, so dividing the array x with array z is equivalent to dividing x with an array z, and that is constructed by repeating the row vector z to obtain an array z, and that has the same dimensions as this one. So let's see, just now I have already the reshape 1:2. So is it possible x will divided by z? So let's see, x is divisible by z, so we can easily get a output. Similarly, I can concatenate z and z, so you can write here z will equal to np dot concatenate bracket and square bracket z comma z, and now comma axis will equal to 0. So let's see this one. Now I am going to print here. So it has been printed like this. Now is it possible to the divide x divided by z? So let's see that, yeah, is it possible to, we can get output. So let us also consider the example like a array z has a shape 2 comma 1, and where the second axis 1 has a length 1. So reshape and then we can solve here. So I hope these are understand. One most important thing you must understand, like if I write here the x will equal to x plus y, and if I write here x will equal to, otherwise you can say right here x plus and equal to y. So there is no difference between these both example. So in place of the operations we can consider the both the statements are the same. So don't confuse about this and this. Similarly, if you write here minus and x will equal to x minus y is the similar. Similarly, if you write the star, so multiplications, slash like a divisions. Okay, so double backward slash means integer divisions and double star means exponents. So the two expressions have the same effect, but in the first case x is reassigned to a new array and y in the second case. So I hope you can understand these things. Thank you. Now we will discuss element wise functions in the next video.